Hi everyone, I'm Professor Rad, and today we are going to talk about simplifying algebraic expressions by combining like terms. Whew, that is a mouthful. So let's break it down and talk this through piece by piece. So you can combine like terms by adding the coefficients of two or more like terms. When you do this, the exponents on the variables don't change. Instead, you can kind of treat them like a common denominator, like they're labels. So in the last video, we talked about how you can identify whether terms are like or not. And today, we're going to combine them. So think about the coefficient, the number in front of a term, like the number. And then the variable components, think of that like a label. Okay? Just like when we were adding fractions, you thought of the numerator as like the number, and then the denominator was kind of like a label. You needed things of the same size. So let's do a few examples of combining like terms. So I'm going to start, the way I work through this is I start out with the first term in the expression, and I try to figure out who else is like this term. So this term has just an n, and there's no exponent written. It's an invisible one, but no exponent written. So I want to first identify all the terms that have n with no exponent. So no n, and no exponent written. And remember, you're going to take the operation in front of the term. That's got n, but it's being squared. N, no exponent written. And then n, but it's being squared. Okay. So I'm going to combine all of these pink terms together by just doing the operations with the numbers. So I'm going to do 4 minus 2, which is 2, plus 6, which is 8. So I have 8n. And I'm going to just kind of keep going on. So the next term that I haven't dealt with yet is this plus 3. So this is a constant term. There's no variable attached. Add a variable. No variable here. And then there's an n squared there. So 3 minus 3 is 0. So let's say plus 0. And then we have the next term is 8n squared. And we have an 4n squared, so they match because n squared. So, excuse me here, I keep shifting my papers. So we have a positive 8 plus a 4, which is a positive 12. And these were both n squareds, so I have n squareds. So when you're combining like terms, those exponents don't change. So I could leave my answer like that, but 0 is the additive identity. That means if I add 0, nothing changes. So we're trying to make this as simple as possible, so I don't have to write that 0 there. So I'm going to write 8n plus 12n squared, and that's going to be my final answer. Now, some teachers might want you to write your answer with the biggest exponent first, but I don't care. So for this class, I don't care how you write your answer. So if we have 8n plus 12n squared, that works well for me. Okay, so I had highlighters for that first one, but let's say I don't have any highlighters handy. Here's another way to kind of help you identify terms as you go along. So what I'm going to do is I'm going to start out with a circle around 2u. So I want only u's, x, ux, u, x, ux. So 2 minus 8, and you can use your calculator here too, that's totally fine. My calculator is not going to have like variables that I'm throwing in here, but that doesn't matter. Just ignore the u and do 2 minus 8. and we get a -6. So I'm going to have -6u. Now for the next term, I'm going to use a different shape. So I'm going to use like a cloudy shape. And this term is an x, nothing else. So ux, x, ux. Okay. So here we have -3 minus 6. Gives me a -9. So I'm going to put in -9x. And then we have 5ux minus 5ux. So 5 minus 5 is 0. But if I have 0 ux's, that means I don't have any, so I don't have to write it. So I can write this as -6u minus 9x. And there you go. That's it. Okay. Let's do one more together then. So we have, let's start out with 1. PV, p squared, 9. There's no variable here. Okay. 1 plus 9 is 10. Now, here we have both a p and a v, and just exponents of 1. So no exponents written. It's got a 2, no exponents, and a 2. So as a reminder, with like terms, the order of the variables can be different. We have a PV and a VP, but P to the first, P to the first, V to the first, V to the first. So we are okay here. These two are like terms. The other thing I'm noticing is that there's nothing written in front of the P. So as a reminder, when you have a term and there's no coefficient written, it's implied to be a 1. So now I have 1 PV minus 8 PV to get a -7 PV. Or I could write that as -7 VP. It's the same thing, it doesn't matter. Okay, now I have -7 P squared V, which is different from this one here. So here the P is being squared, and here the V is being squared. So these two are not like terms. They don't have any buddies to match up with, so we're just going to repeat them. So, it doesn't look like we made this a whole lot simpler, but it's a little bit simpler than it was before. All right, so that's gonna wrap it up for this video, how you can combine some like terms to simplify expressions. In the next video, we're gonna talk about another way that you can simplify expressions. And in those techniques, not just the numbers in front, but the exponents are gonna change too. So we'll talk about why that might happen then. In the meantime, I hope you found this helpful, and I will see you next time.